An adult scallop population is known to be normally distributed with a standard deviation of 5.9 grams. If 15% of the scallops weigh less than 58.2 grams, find the mean weight of the population. Right, so we have a problem, we have an unknown mean. Before I say anything else, I will say that whenever you have an unknown mean or an unknown standard deviation, you always need to transform onto the standard normal distribution. So before we do that, I'm going to define the variable. So let x be the random variable let x be the random variable, and it's going to be the weight of a scallop. Of a scallop. How do you spell scallop? S-C-A-L-L-O-P. The weight of a scallop. Right. So x, we've been told, is distributed according to a normal distribution. We don't know the mean, so that's mu. We do know the standard deviation, it is 5.9, so the variance is 5.9 squared. Right, and then we have been told 15% of the scallops weigh less than 58.2 grams. So the probability that x is less than 58.2 equals 0.15. Okay, so now, if I draw a little sketch, now remember I'm trying to show you a really formal solution, or nearly. I kind of skipped one bit, but I'm going to draw the sketches. I think it communicates everything really well. It helps my explanation, I think. So there's the normal curve for x. This is x in grams, right? Right, so we have an unknown mean, mu. And we know that 15% of them weigh less than 58.2. So less than implies that left tail. 15% is not that much. So somewhere around here, we have an area of 0.15. That is made true by a weight of 58.2 grams, an x score of 58.2 grams. So what we are going to do is transform this x score into a z score. We're going to standardize it, and what I'm doing, I'm going to try and mirror this curve. I'm going to convert it into a z. Right, so we know the z distribution. If I can just bring this mu down into here, z is distributed normally with a mean of 0 and a standard deviation and variance of 1, because 1 squared is 1. So this is 0. If we're still interested in the same proportion, so 0.15%, so 15% of values are less than some z score. I want to know what z value makes that true. And I should be able to find that because I can use inverse normal, and I have a mean and I have a standard deviation, so that's quite good. So if you look on a mark scheme, you will see there's, for finding this z value, there are definitely marks available. So what I'm going to do, I'm going to go to statistics. Remember, if ever you have a probability and you're looking for a score that makes a probability, you need inverse normal. So distribution, normal, inverse normal, variable, yes, yes, left tail, yes, area is 0.15. And actually, it's already on the standard normal distribution. If it wasn't, just put it in. But sigma is 1 and mu is 0. So that gives me an answer of minus 1.036. Z minus 1.0364334. I need a lot of accuracy on this as well, because I'm going to use this number in a calculation. So this is a z score, and remember, as your formula book will tell you, if you want to convert x to z, to standardize something, z equals x minus mu over sigma, right? So the z score, such that 15% of the values are less than it, is the same as the x minus mu over sigma. Right? So this minus 1.0364 is x minus mu over sigma. So now I can write x minus mu over sigma equals minus 1.036434. And I know x, I know sigma. The only thing I don't know is mu. So let's put it in. X was 58.2. 58.2 minus mu over sigma is 5.9 equals minus 1.036334. So from there, it's really quite a nice, or quite a simple rearrangement. You're just going to multiply by 5.9. 58.2 minus mu equals minus 1.036334 times 5.9. So if I just add mu to both sides, subtract this to both sides, I can solve for mu. So mu equals 58.2 plus 1.036334 times 5.9. And then I can get a mu. Let's go to the calculator. Main run matrix mode, 58.2 plus 1.0364 times 5.9. And that gives us an answer of 64.31. So three significant figures, 64.3 grams. And if you look at the diagram, could you believe that that is 64.3 grams? Well, you know the standard deviation is 5.9. So if I say took 6 away from that, takes me to sort of 58-ish. You're saying this is sort of one standard deviation away. It looks pretty good, I can believe that. So all you need to do, if ever you need to find an unknown mean or an unknown standard deviation, you need to standardize, find the z value using inverse normal that makes that proportion true, and then just equate that to your x minus mu over sigma, and you should be able to substitute and solve.